Lesson 5.6 is called Half Angle Identities. So with this last section of chapter 5, we will recognize the half angle identities and their formulas. We have 3 half angle identities that we need to learn. If we're going to find the cosine of any half of an angle, that's cosine of A over 2, we will need to calculate square root of 1 plus cosine of A over 2, and we just have to decide the sign depending on where A over 2 lies in, whether quadrant 1, quadrant 2, quadrant 3, or quadrant 4. So this is the formula we need for cosine A over 2. For sine of A over 2, we will calculate square root of 1 minus cosine of A over 2, and then we have to think about the sign, whether the half of the angle depends on the quadrant 1 or quadrant 2. And finally, for tangent half of the angle, we can calculate its value by taking the square root of 1 minus cosine alpha over 1 plus cosine of alpha. As you can see, this formula comes from tangent being the quotient of sine over cosine. So the root 2's cancel each other in the denominator, and this becomes the tangent alpha over 2. You can also use 10 alpha over 2 by using this formula, sine A over 1 plus cos A, or you can use the formula as 1 minus cosine A over sine A. So the first question here is, we want to find the cosine 15 using the half angle identities. According to the previous slide, cosine 15 is half of 30, so A over 2 is 15. That makes the A value to be 30 degrees. So the formula we need is square root of 1 plus cosine of 30 over 2. And there's 2 options, either positive or negative, but 15 degree is in quadrant 1, so we know that we have to use the positive version of this formula. And cosine of 30 is equal to root 3 over 2. When we add 1 to this, 1 can be expressed as 2 over 2. And when you combine the 2 plus root 3, that makes your numerator to be 2 plus radical 3 all over 4. And then divide it by 2 and take the square root. That expression will mathematically simplify to this for cosine 15. For tangent of 22.5, we know that 22.5 is 45 divided by 2. So we know that we need to use the half angle identity. And then you can use any formula for tangent, but the textbook chose to use sine A over 1 plus cos A. So we will need sine 45 divided by 1 plus cosine 45. Sine 45 is equal to root 2 over 2. Cosine 45 is also root 2 over 2. Because of the radicals, simplifying is a little bit challenging, but it's not impossible. When you do a lot of fraction and radical division and multiplication, the answer will simplify to root 2 minus 1 for this problem. Now, if we look at the last example for this section, we have cosine of S is given as 2 over 3. And the question says that angle S is between 3 pi over 2 and 2 pi. That makes our S to be a quadrant 4 angle. And it is asking for me to calculate cosine of S over 2, sine of S over 2, and tangent of S over 2. So we will need the formula for cosine S over 2. This is the half angle formula for cosine. If you go back to the very first slide in the lesson, its formula is 1 plus cosine A over 2 in a radical. So we know that this is 1 plus cosine S over 2, and then it might be plus or minus. So we're going to think about this. For S over 2, let's find the interval. Half of 3 pi over 2 is 3 pi over 4. Half of S is S over 2, and half of 2 pi is pi. So S over 2 is going to be an angle between 3 pi over 4 and pi. So 3 pi over 4 is here, it's 135, and pi is 180. So half of the angle is in quadrant 2. So S over 2 is an angle in quadrant 2. And in quadrant 2, cosine is a negative value. So when I'm using this formula, I will make sure that the cosine value I am getting has to be a negative value. So when I keep calculating this, I will need a negative square root 1 plus cosine of angle S, which is 2 over 3. And then we're going to divide this by 2. And negative again. And then instead of 1, we can write 3 over 3. And when I add it with 2 over 3, that makes 5 over 3. And then we're going to divide it by 2. Copy the first one, multiply it by the reciprocal of the other one. That gives me a negative radical 5 over 6, which will just be negative radical 5 and radical 6. When I multiply top and bottom by radical 6, that's negative root 30 over 6 is the half angle cosine value. Similarly, sine of S over 2, in second quadrant, sine is positive, so I'm going to use the positive version. And the formula is 1 minus cos S over 2. So it's going to be a positive value, and it's 1 minus 2 over 3 over 2. Instead of 1, we can write 3 over 3. So when I subtract 2/3 from 3 over 3, I just get 1/3, and I'm going to have to divide it by 2. So copy the first fraction, multiply it by the reciprocal of the other fraction. So we will get 1 over 6 here. When I take the square root of top and bottom number, radical 1 is just 1, radical 6 is root 6. When we rationalize this fraction, we're going to get root 6 over 6 for the sine value. Now for tangents of S over 2, my work is a little easier because tangent value of any angle is always its sine value divided by its cosine value, right? And the sine of S over 2, we got it here as root 6 over 6. And for cosine S over 2, we got negative root 30 over 6. So when I'm dividing these two fractions, I can copy the first one and multiply it by the reciprocal of the denominator. So these two will cancel out. And positive divided by negative is just negative. Then I have a root 6 at the bottom, and I have a root 30 at the top, at the bottom. I have to keep simplifying this. There's other ways to simplify, but what comes to my mind is root 30 can be written as root 5 times root 6. So the top root 6 and the bottom root 6 cancels out. So far, at the top, nothing left. So that's just a 1. At the bottom, we have a root 5 left. And then to rationalize the denominator, we have to multiply top and bottom by root 5. So that gives me a negative root 5 over 5 as the tangent of S over 2 for this question. Good luck for the 5.6 homework, very short homework.